Hi, and welcome everybody to our 7th live stream here from York in the north of England. Welcome wherever you are around the world. This week, as the past few weeks, we're going to be looking at our early 19th century long case clock. Nice to see people popping up already in the live chat. So as always, we've got Team Open Clock Club on hand, who are going to our 7th live stream here from York in the north of England. Yeah, get rid of that. And so please let us know where you're from in the live stream, and importantly, what you've been up to. Quick word about the other things that are going on. It's been actually quite nice because I've been out on site this week, not doing exactly horological stuff, but things with tools and like watchy type things, although I'm not a watchmaker. So anyway, you could catch up with that stuff on Facebook. As always, thank you to our great team of contributors to Facebook. You're really helpful, and we here at How to Repair Pendulum Clocks really appreciate that, so thanks for that. Okay, so our long case clock, you may remember that last week we did our preliminary cleaning. So I basically break the cleaning down into 2 stages. I do the first stage, the preliminary stage, to get the kind of worst of this sort of oil and dust and dirt off the surface, and then I do all the repairs, and then I'll do a secondary clean, and then the job's done, he says. And 2 weeks ago, we identified most of the repairs that need doing, which we're going to start working through. But when I did the cleaning, and this is really a kind of one of those usual soapbox moments, is that in the Facebook group, and I don't follow that many fora to do with clock repairing and things, but I'm a big fan, you will know, of manual cleaning, or really washing, which is what we do. So that's working with each individual component and washing in mineral spirits. Well, I've gone on about that enough. I don't need to repeat it again. It's in our book here, How to Repair Pendulum Clocks, and it's on Facebook and all that stuff. And the beauty of that, of course, well, there are many advantages, I think, but one is that you really get time to look at things that you might not otherwise if you were cleaning en masse, or in some kind of putting everything in together in an ultrasonic or something. And one of the things I noticed, which was actually kind of quite obvious when it came round to it, was, just need to get my camera, there we are, was this click spring here. And you can see it's fractured. So when I first saw this, I was, of course, when you see something that's broken, you're, you know, one's heart always sinks a bit. And, but anyway, it is. And they often break like this through the rivet. This is kind of one of those components on a long case clock or a tall case clock that it's easy to kind of say this is a design flaw. With a spring, it's kind of, I think, a form of beam theory. So if you imagine the roof joists in your house, or the floor joists in your house, they're situated like this with the load here, because the strength of a beam is proportional to the cube of its thickness. So what you don't want is the floor joist to be like this, unless you want a nice sprung dance floor, that is. But with a spring for a clock, like this spring here, sometimes the spring is like this, which makes a whole lot of sense. But in this case, it's that way on. So it's actually not particularly kind of springy. Now, I don't know when this fractured here, but another beauty, if you like, of, let's just move that click out of the way, of not kind of completely refinishing with cleaning, is all the witness marks. Witness marks are really important, I think. And you can see here, if I just move the click spring down and that round. You can just about see there, look, the shadow from when this click was longer, the spring was longer, sorry. So what's happened, conjecture, he says, is that the tip has broken off and it's been shortened, and you can just about see here, there's a whole lot of marks where it's been handled with pliers or something, and you can see the mark underneath. So it's come up here, much closer to the pivot of the click. Now with a leaf spring like this, you want the spring to come as close to the pivot of the click as you can, with it still functioning. That means the action of the spring and the click can remain light, and the spring doesn't have to travel very far. The further it is away from the pivot point, of course, the further the spring has to travel. So this has been shortened by the look of it. And I imagine when they shortened it, they took it off, and when they riveted it back on, and I don't know how closely my camera will focus in, but you can see there, look, there are hammer rivet marks, which has split the spring, and also one probably cross pane hammer mark on the wheel tooth as well there. So, you know, I'm not going to worry about that too much. But the problem is that I don't think I can repair this spring. And the reason is because of that beam thing that I talked about, that if we were to, what I'd normally do probably is to solder, soft solder on a plate of material here. But for it to be strong enough, I double the thickness, which is going to mean that this part is like not springy at all. Again, in the live chat, please let me know what you would do. Sometimes on these, what you see, and I quite like it actually, it's just a piece of hard brass wire has been threaded through the hole. So out of here, comes around here, back underneath, across the other side and through that hole. So just a bit of wire threaded through. That works really well, but I guess it would be frowned on, maybe if I were to repair it that way. But that way, of course, would take about 3 minutes to do a repair. So I'm thinking that I'm going to make a new spring. Now, of course, it's always tempting to improve the design. If I was going to improve the design, I'd make it a lot thinner, particularly at this end, so it can actually move more in a spring-like way. But then, I mean, I'm not trying to reproduce this spring per se, because it won't be the original spring. I can't really think of another way around it. I can't solder something on here because it's not going to be springy, although we could try that first, but it doesn't get around the fact that it's also been shortened as well. So I think a new spring is in order, and I'll probably just copy this. I might make it a bit thinner, but then I'm into the realms of improvement, or what I think is improvement, which of course has got nothing to do with what anybody else might think is improvement, and we're into slightly dodgy ground. Just another thing here before we move on, and that is normally when you clean a clock, you reasonably try and take it into as many parts as possible so you can clean threads and things. And so what you would normally do is you gently lift up the spring like this, and you can unwind the click. The click in this case is threaded into the wheel rim, but it's been riveted in. So it's like, oh, what do I do here again? Do I unscrew it and kind of force it out, and then I'll be left with it being sloppy? I bet it never needed riveted in. I think people see it wobbling about with wear and think, well, I don't know what they think, of course, but maybe they think it's going to fall out or something, which it won't until that wear gets incredibly bad. So you often see these riveted. The other one wasn't riveted, and I unscrewed it. In fact, I'll get that, then you can see what that's like if you haven't seen that before. So I reckon that is a job. We've got some live chat I think I need to pay my attention to.
So it's simple to replace.
Yeah. Oh, well, for those of you that watched our Icon event on Monday night, it is gonna go on Icon YouTube, by the way, so you can catch up with it. It's not there yet. It's going to take quite a while. but we talked about marking new parts. So great. Thank you, Jeremy and Derek, for that suggestion. I will make a new spring because, of course, in this situation, it's not only doing what I would do as a kind of practitioner conservator, but it's doing something where we all kind of kick it about. And maybe at the end of the day, we also learn something. We've already seen on this channel and on our other channel that we make loads of mistakes anyway. So that's good. We learn probably more by them than anything else. Right, we're going to make a new spring. I'll just get the other wheel. So for those of you that have never seen one of these great wheels before, I can demonstrate how the click works. And then we've got an unboxing to do. Then we've got some depthing to do, our favorite thing. And then we'll talk about this. So work to keep us busy forever. Oh, it's there actually, isn't it? So here's the other great wheel. You can see straight away that this is the striking side and this is the going side. So these wheels are on a common sort of horizontal line in the clock frame, and they're a common distance from the center wheel. So the only way you can stop them both engaging at once is to make one a bit smaller than the other. So the same thing. And it's quite nice here actually, because if we look here, we can see that this spring as well has also been manipulated with a pair of cutters or something, but I don't think this is shortened. And that's quite useful when we come to designing our new spring. Yeah, you can see there, look, the difference in distance between the end of the spring and the pivot hole and the end of the spring and the pivot hole. This is kind of half that value. So that's really great. So that gives us some kind of guide for making the new spring. So that's nice. Yeah, sorry, I was going to show you, wasn't I? So here's the click. Here's the click even. It's worn a bit underneath. No problem there. And of course, it's like not a particularly good idea, again, in terms of design, but you know, we have to shrug our shoulders and rejoice at how incredible these clocks are. That this is reciprocating, of course, every time the clock gets wound, and the threads do wear. On like posher clocks, some of you may have worked on those clocks, this is actually screwed in as a separate component from the back, and it means that the screw is static in the wheel rim, and there's a sort of proper, if you like, bearing in here. But anyway, so to get the click out, and this is sometimes a bit of a question as to whether you take the click out at all, because you need to lift the spring. So you can wind the click in, oops, he says. Can I wind the click in? There we are. So you can wind the click in so far, and then of course it jams against the spring. That's the last turn we'll be able to do. So to get it to go down the next turn, you have to lift the spring over the top. Now you might say, well, Matthew, that's why it broke. But it's not, because of course lifting the spring this way doesn't stress this rivet here, although it does look like this one's been re-riveted too at some point, so they've both been taken off. Now I can hear somebody out there saying, well, why don't you take the springs off to clean the thing, because you can't clean properly, whatever properly is, underneath. And that's kind of an interesting question, really. But I mean, you could quite easily file off these rivets, take those out, put new pins in every time, if you wanted to clean under here. But again, remember, this treatment, or what I call practice, is a cost-benefit exercise. and the cost to the clock, I don't mean the monetary cost, I mean the cost to the object of filing these out off and putting new pins in every time is greater than the benefit of being able to clean underneath here, which the reality is it only moves like that anyway. In fact, let's get our great wheel. I don't gritty cobs in there. Just get our great wheel. Sometimes these are, well, they're not interchangeable. Right. So that one doesn't appear to fit. There we go. So for people who maybe haven't seen one of these clocks before, the gut line threads into a hole there, look, see that hole? And there's the ratchet, there's the click. This is quite interesting in terms of making our new click, so we can see the amount of sort of a deflection that spring has to go through. And you can see it's a nice sort of rapid clicky action. Anyway, so that's what we're after there. Useful. I mean, I haven't made any effort to get these gritty cobs out of the drying media out of the barrel, but that's why an airline is really useful. If you've got the luxury of an airline in your workshop, then that's brilliant. We all love tools. So just going back a step, as we like to do, and we've still got the studs in our front plate. And you might remember that last week, or the week before, in fact, I said I would order some flat nose pliers to get these studs out. So I've done my preliminary cleaning with them in, which I wouldn't normally, but the pliers hadn't turned up. Oh gosh, I bet we're all really looking forward to doing that rack spring, which I'm still half thinking how I can convince you to keep it. But anyway, it's gorgeous, isn't it? Look at it. Anyway, so we've got our pliers have turned up. So I'm going to do the unboxing and get those studs out, and then we can check our depthing, see if there's any bushing needed. So let's just get that out of the way. So these are from, yeah, they're from Cooks and Gold. I think they're called the jewelry gold suppliers. And they're really good. I like the service. They've got a nice clean website. I don't really know what they're like on price, but I've never owned a pair of these flat bladed pliers. So let's have a look what we've got. Invoice. Here we are. Ah, look at that. The classic model, classic parallel pliers. Sturdy construction, contoured handle, parallel jaws, apply even pressure. Pro quality. Oh dear, that's not me, but anyway. That's you people. Perfect. Okay, let's have a look. It's like a real YouTube channel, this, isn't it, with the old unboxing now? And oh, they're quite, you can see straight away, they're quite sort of short in the handle. Be a bit nicer if they were longer, but you could actually extend them. But what's important to me is that they've got these brass lined jaws. So they look great. They look just right. Oh, how much were they? They were, let's have a look at the invoice. $12.99 plus VAT. So your maths is better than mine. $12.99 plus 20% VAT. So probably £1.20, £2.40, 15 something, £15 something, including VAT. I think they're quite cool. I'm reasonably happy with them. But let's see if they do the job. But before that, of course, with any new tool, any new thing, a computer, camera, what you've got to do first is to hack at it with a file or take it to pieces and leave it in bits for a few weeks. So that's what I'm going to do here. I could actually take it apart, but I'm not going to do really. But what I'm going to do, you can just see here, look, the steel bit and the brass bit are the same length, and I don't want this steel bit touching the frame, so might just have to. Because the steel part here, I'll go back now, I've finished it. I was just filing them back. So the steel part, I don't know if you can see because the contrast is not very good on the camera, but there's about maybe 1.5 millimeters or 2 millimeters of brass, and then on this steel backing. And I don't want the steel backing to touch the clock frame. I only want the brass bit to touch the clock frame to prevent scratching. And the same thing, I'm just going to look on the inside. The jaws are actually quite nice. Yeah, they're actually quite smooth already. So I'm okay with those. But of course, with them being parallel pliers, you can just get that burr off there. Yeah, they're nice. Let's see if they work. Yeah, once I've finished with them today, I'm going to send them back and say they're no good. They were never right, and they were always like it. Oh, they're really great for this job, because the point is here, of course, is normally I would use one might be tempted to use an adjustable spanner, but adjustable spanners are broadly banned. I'm, as you know, no engineer, but I do get why an adjustable spanner is a bit of a sort of last option. So this one is my kind of favorite for this kind of thing. But as you know, A, it's obviously got steel jaws, but B, they can wear in here and you might end up rounding the squares off. So I thought it would be good practice to just move that out a little bit, to try these. Yeah, they work really well. Really pleased with those. I'm afraid that's something that I should have bought years and years and years ago. And of course, with them being brass lined, I suppose once they get damaged, you could always reline them. But also you can just use them. I think we were talking last week. Sometimes you just get something that needs gripping, but you don't really want to hold with steel. And then you can file this away, you can cut parts away, and it's not the end of the world. And you can, I don't think you can see that with a camera. Let's try this one here. There you go. You can see the point of me filing the steel away. If this stud wasn't square with the frame, which it probably isn't, as I rotated the plier, it might just catch on the frame and scratch the material, whereas it is, it's away from it. So I would say that's a bit of a result. So a product review and unboxing all in one. So let's just get these out. I did notice, or we noticed, should I say, a couple of weeks ago when we're doing our repairs, that they're not interchangeable, these, by the way, so I don't have to worry about making sure they go with which hole. You might remember that this stud, the minute wheel stud, I think it is broken through, cracked through on the edge. You can see there or not. So I'm going to have to straighten this and then probably silver solder it to strengthen it. I could leave it. I mean, it's going to hold. I could straighten it and leave it. The problem then is, again, it's that issue of, do you, what's the word? Do you legislate for future repairers? And the answer is broadly no, you don't, because you've got no idea what they're going to think or what they're going to do. However, I might solder that just to give it some strength. I suppose the thing is, if it breaks off, then you lose the end and then you're gonna have to solder a bit on. So anyway, that's just one of our many, many repairs. So bushing, everybody's favorite subject after or following cleaning. Let's see if this clock needs any bushing, and the answer is no. That's my default answer, is it doesn't need bushing. I need to be convinced that it does, rather than the other way round, which seems crazy, but that's just the way I prefer to approach it. So how do we know if it needs bushing? We all know that the pivots jump about in the holes when you wiggle them. No, that is not, that's an indication that bushing may need doing, but it doesn't tell us to bush. Please don't bush if the pivot jumps about in the hole. That just tells you that it's an indication. The pivot not jumping about in the hole on a clock that's 200 years old might equally need bushing. We know that there's all sorts of repairs taking place on this clock. So the way, and I apologize if this is repeating things from the Open Clock Club, but the way we're going to tell whether it needs bushing or not is we're going to put the mobiles in the frame in pairs and try them. First at a kind of neutral position, second at their most pushed apart position, so when the depthing is shallow, and third when they're pushed together. So without going again over all ground, the broad idea with bushing is that when a pair of mobiles or gears, let's just get oh, I love adjustable spanners. I just get told off if I ever use them. That's the difference. In fact, one of them, let me get started on a adjustable spanner talk. This one I had ages ago, and then I was cycling in the old, this is like 30 years ago or something. I used to do a lot of cycling. I was cycling the Land's End John O'Groats, and I found this spanner on the roadside in Scotland. And it's nice because it's got the kind of parallel handle. This is only a small part of my collection. I've got at least another half dozen as well, but just not allowed to use them. Right, okay. So without laboring, let's get this right. So in any, let's just say we've got multiple intermeshing gears. Well, for the sake of this, let's just take two at once. So, oh, we might have an internet problem. We make these things as a clockmaker, and then how do you know how far apart they go or how close together? Well, they're designed on a thing called pitch circle diameters. There's a theoretical diameter where in this case, the driving wheel and the driven pinion should mesh. And that's the optimum position. And that position is determined by the distance between the axis of this wheel and the axis of this wheel, which we call center distance. So if the center distance increases, then those two theoretical circles, the pitch circle diameters, move apart. They should be touching, and if the center distance decreases, then they overlap, and that's called the depthing being deep. So we want to determine whether these wheels are at their optimal or near their optimal depthing, because what happens, let's say this wheel here, the center wheel, as we're looking at it, if I got this right, rotates clockwise, doesn't it? It's got the minute hand on it. So the third wheel, or upper intermediate wheel, as I love to call it nowadays, rotates counterclockwise. And every action has an opposite and equal reaction. So as this rotates, it's pushing the third wheel in this direction, and the third wheel is pushing the center wheel in this direction. So the bearings, the pivot holes, elongate. This is only typical, it's not always happened that way. And as the wheels move apart slowly, and also the wheel wears smaller and the pitch circle diameter of the pinion wears smaller, what happens is there's what we call action before the line of centers. And action before the line of centers results in engaging friction. And basically, to cut a really long story short, it means your clock stops. And what you have to do is to return the wheels to a more optimal center distance. So whatever you hear and whatever you read about bushing, if you do bushing, do depthing first. Bushing without depthing is, I don't know what it is. Often wasting your time and often doing work that doesn't need to be done. So let's just take these two wheels, for instance, and let's just check them. You don't need a depthing tool for this normally. Let's just check them in the frame. It's the quick and easy way to do it. Now I'm going to have to just move that out a little bit. So let's pop our center wheel in. Right, okay. Well, this actually might be difficult. I forgot this center wheel needs a new pivot on the half the pivot has disappeared. But let's continue with the demonstration for the sake of argument. So third wheel goes in there, or upper intermediate wheel as we call it. And let's put the frame together. Yeah. Oh no. That's because I went on the bike, I didn't walk. That's why. No, so walking and cycling are really great ways to spot tools. You see, as you, I don't know whether people who don't cycle or don't walk don't see this, but on the open road, you see like hundreds and hundreds and hundreds of nuts and things that have fallen off vehicles, and you think it's good that we've got an MOT. Right, okay. So let's just quickly run through this kind of theory of how we check the depthing. So we've got our two mobiles here. I might stand up to make life easier and also close the blind. Yeah, I must say, going from Land's End to John O'Groats was not a good idea. I don't know why they don't call it the John O'Groats to Land's End. Nothing against either of those places, but traveling south, we did it in April, and it was, I think, 13th of April, 15th, and it was like really thick snow. I would have preferred to have been going in the direction, but anyway, enough of that. So here's our two wheels in the frame. So we know at some point, we presume, we don't know anything, we presume these were depthed by the manufacturer, by the maker, and they planted them, they put them in the frame at an optimal center distance. And we kind of think maybe over time they've worn apart, because that's typically what happens. So the first thing to do is just to, given that our pivot actually needs replacing, is just to rotate back. Can you see the upper intermediate wheel pinion is worn? That's not a problem per se. The problem with worn pinions is when they wear past the crest of the pinion leaf and the pitch circle diameter begins to reduce kind of significantly. If you imagine X amount of wear on a pinion is, and the same amount of wear on a wheel, the wear on a pinion has a bigger effect because it's a larger proportion of the pitch circle diameter. Right, okay, so you can't, I'd see a lot of people spinning the wheels, totally pointless. I mean, it's good fun, but totally pointless waste of time. So what I'm doing is I'm applying a bit of load to the driven wheel here, the upper intermediate wheel, also known as third wheel, and I get a kind of feel for how smooth the engagement is. You can actually do it like that. So I kind of get a sense of how smooth it is. Now what I'm going to do is I'm going to force the wheels apart, press the wheels apart, again under load, and I'm going to get a feel for how they feel relative to that first position in terms of smoothness of transmission of power, because that's our best way of thinking, can we improve that situation, this situation? And that's the question. Through bushing or changing the center distance, which is what bushing is, can we significantly improve the transmission of power? Can we make a big difference, or a difference that's great enough to warrant the intervention? So if when they're apart like this, there's a significant loss of smoothness or more friction, and when they're together like this, that situation improves significantly, then yes, you maybe have to bush one or both, one or more of these 4 pivot holes here. But if there isn't, if when you go like that and you go like that, you can't tell any difference, which is the case here, of course, then irrespective of whether the pivot flops about in the hole, when the clock's running, sorry, I'm on my soapbox now, I'll climb off in a minute. When the clock is running, other than the escape wheel to a degree in the pallet arbor, the pivots don't wobble about in the holes, they're pushed to one side and they stay there. So here, I can't detect any difference between those 2 positions. So for me, there is no advantage to be had in bushing any of these 4 pivots. Now, if the transmission, and you have to kind of learn and get experience, of course, if the transmission power is really poor within the frame, and I thought there's something wrong here, then that's where your depthing tool comes in handy, because you take them out of the frame. I'm using the frame kind of like a depthing tool, really. Take them out of the frame and try them in a much wider range of center distances. But here, I'm not a betting man, but this is fine. I mean, this is fine. No bushing needed there. So we're just going to quickly run through the train. And so if you find yourself or hear anybody bushing without doing this process, like what's going on? Anyway, now we can see here, look, that bushing has already taken place. I would be surprised if that hole needed bushing, who knows? But let's just try it. Not that one, wrong wheel. Takes, obviously I'm doing it on the camera, so it takes a bit longer than it would normally. Sit down again. So exactly the same process, got our 2 wheels in the frame. I think it would actually be useful to pin the plates. Maybe I'll put 1 pin in. So this is the escape wheel running clockwise. So that's in the forced apart position. That's in the earlier maybe position of unworn. And I can feel a difference there. It is definitely, because I'm just, it's squeaky. Difficult to say. I would say it was slightly better in the closer together position. So on my day book or in my mind, I'm thinking, right, okay, let's have a look at this. I'll look at it with an eyeglass, and you can kind of have to guess where the pitch circle diameter is. But I'm thinking, okay, is it worth moving this bush here further closer towards the third wheel. Well, if I maybe wasn't doing it live, you would take them out, put them in the depthing tool, then you can compare them to the holes in the frame. But the point is that the transmission of power, a bit rusty, isn't at all what I would call bad. I mean, it's a bit lumpy. And yeah, it's not perfect. I mean, that's the other point here, that rarely do you feel these mobiles and you think, gosh, that's really, really smooth. It's maybe slightly worse when it's in the push to part position, but I'm not going to push it. It'll remain in my mind or in my daybook, and then let's see how the clock runs. But if you can see there, but it's a little track. And again, don't worry about these worn pinions when they're like this. When you think about, I've often seen people reducing end shake and thinking, well, what happens if the wheel suddenly starts to run on the unworn part of the pinion? Well, it's not going to do it. It'll just go in that track and it'll stay in that track. You do often see wheels that are dished, that are kind of cupped across to run on a new piece of pinion. And whether you straighten those up or not, I don't know. We'll come across one day in our travels. It's okay. I mean, if you've got it, I mean, you can just about see there that it doesn't bind up, but you can feel there's more friction on that incoming pinion leaf, the escape wheel pinion leaf. So that's friction before the line of centers. If you want to test a clock that you think might be butting that situation and might need bushing, just put a bit of lubricant on the pinion as a temporary measure, so a bit of graphite or a bit of oil, and see if the clock runs. So let's just quickly go back to our great wheel. Yeah, thank you. If you've got a dilemma, you can ask for advice. It's a good point, but I think if more people, I mean, I don't know what people do, but what I see, or I think I see in my paranoia, is people seeing the pivot jumping in the hole, or not even that, just saying that clock needs bushing. Remember that these clocks, this is a manufacturer clock, but not a kind of interchangeable parts clock. The oil sink has got nothing to do necessarily with the center of the bearing, so you can't take that. I would never take the fact that it's off the center of the oil sink anyway. You don't know whether the oil sink's got anything to do with the center of the bearing. Again, it can be an indication, it can be a guide, but returning through bushing a pivot to its middle of the oil sink, it needs to be to do with depthing. That's what we're interested in. Have I gone enough about depthing, do you think? Maybe I should go on about it a bit more. I'll get on to pivot polishing in a minute. Sorry. Half a pivot, center wheel. All right, okay. I was thinking then, are these barrels so close that they're interchangeable, and they're not, of course. What I've done is I put that on there, but if you look there, that's a striking barrel. And I suppose some kind person might have actually put an S on it at some point. Can't actually see one. I'm sure there's one there. Pretty unusual if it wasn't. So we can presume that this is the going barrel. From there. Oh, slip washer. There we go. Exactly the same, despite what I said, I just spun the wheels around. Don't spin the wheels around. Let's just see if I can get my... It's better when that pivot's replaced, won't it? Dropping out the hole. So I got my fingers in there, let's see. All right, well, this is quite cool because this is one of the opposite to the escape wheel and third wheel. This is actually smoother when they're pushed apart. And you'll often find that's the case. So pushed together, they're quite lumpy, and pushed apart, they're relatively smooth. Cool. That's done our go inside. Nothing there that we will get that arbor straightened up eventually. Nothing there that alarms me. So on the basis that that was the going, that must be the striking. You know, sometimes you just look at all these wheels and totally forget where they go. Right, okay. So, no, don't would help. Or the obvious mistake.
It's just the arbor is making him seasick.
Oh, it's terrible, isn't it? I know. Won't it be lovely when it's straight? Won't it be lovely when the clock's finished and we can have a week off? Right, okay, same thing. So this is, it's, get the direction right. So it's winding in that direction. Running that direction. Yeah, interesting that this one is, I think it's just the way that they wear on the back of the teeth, I don't know, but it's smoother in the direction of rotation that it runs, which I think is that way, isn't it? Yeah, it runs that way. Then it is that way. You can hear that on there. Anyway, smoother in that direction. You'll often see that if the pinion, I suppose here it's not that simple when you're making a clock, but if you don't cut your pinion right on the center line, doesn't matter again for a wheel so much because it's a much smaller percentage of the diameter of the wheel. But if you don't cut a pinion leaf straight on, then it makes a massive difference to the smoothness of engagement. And sometimes sort of 50% of the time you're lucky because it's on the right side and it's sort of an improvement, and 50% of the time it's on the wrong side and it needs to be redone. So gathering wheel and pinwheel, nearly there. So exactly the same process. Yeah, this is another one that's smoother further apart than it is closer together. So happy with that. Warning wheel. All right, this is the one with the extended bush, which of course does make, oh gosh, and the warning wheel's all wobbly. Anyway, does make the reassembly slightly more difficult. Let's just. Oh, that's quite interesting because this is the worst one yet of all the pairs of mobiles. This is going to be the noisiest one. So let's just for, we'll do the fly and then we'll go back to this. Let's just for an exercise. Is that the same the whole way around? Sometimes on striking trains, you find, you remember the fly spring on this had been put around the wrong side of the arbor. Sometimes you find it's a particular place where the depthing is bad. But actually here, sorry, it's difficult to see, no light. There isn't a whole lot of difference between pushed apart and together. They're both not smooth. This isn't going to cause a problem with the clock running, but what it will do is it will make the striking train quite noisy when it's running. You sometimes get that on fly. So let's quickly look at that in the depthing tool as well. So gathering to warning, and last but definitely not least, let's just do the old fly. Yep.
There it says when he does that, he checks end shake at the same time. When do you check for end shake?
That's a good point. Yeah, I wouldn't on a clock. I mean, you should, absolutely should. I haven't been checking end shake, as you can see. I mean, I think taking the wheels in and out, you would just kind of get a feel for it. But that's a really good point, Derek, that always check for end shake. I mean, the only time I would really sort of hone in on that is if I see any recent bushing, because bushing, as you know, I'm paranoid about it, try to avoid it at all costs. But then you often get uprighting issues and you get that problem with end shake, as you say, and also the inside of the new bush being sharp and it binding up on the inner kind of shoulder of the pivot where it meets the end of the arbor. So yeah, absolutely right. Good point. It's really useful. And I think a lot of the Facebook people who I see who are rather courageously repairing 3-train clocks. I mean, it's a good old challenge doing that. And I think what happens is that they've either bush a lot, or they buy clocks that have been recently, seen a couple of Facebook people this week that have bought clocks that have like just sold has been restored. It's like, wow, you deserve a medal for your courage. Because it's all that recent bushing that causes more problems than anything else in my experience. So absolutely check end shake. We'll just, thank you for reminding me. So I should have taken the fly off its arbor really to do this, but let's just get our finger in there. Push them together, rougher together than apart. So the one kind of potential thing here, I wouldn't normally bother with it, but what I will check it with the depthing tool because we're trying to learn stuff, is the gathering to warning wheel. So, it's a better picture look of our straightening the fly spring up. It's not the most like super neat thing, but it's doing the job absolutely fine. We didn't have to remake any part of it. Perfectly happy with that. So end shake. I can't really show it because of the camera angle, but I can up here. What I would do, if you're worried about end shake, and it's a really good point, is just get this in here. Yeah, I mean, too little end shake is the problem here, not too much end shake. I mean, if you've got massive amounts of end shake, obviously to the point where the pivots are going to come out the holes, and that is a problem. But normally the wheels don't move around like this. Maybe on a striking train, the fly kind of jumps about a little bit, but particularly in a clock like this where the pinions are worn, the wheels and the pinions go in the tracks. It's a bit like Herculaneum or Herculaneum. You know, those trucks get in the tracks and they kind of stuck there. So to test end shake, you can see against the colour of my jacket there, the first thing is just to put the frame like this and check, can you hear it, that the wheel drops completely cleanly onto its shoulder. Any hesitation there whatsoever, you must investigate, because what will happen is it'll bind up. So we invert the frame. In fact, so if you can hear that, that's exactly what you should hear. All the mobiles should drop under their own weight. So we test it both sides. Then we do give it a bit of a spin. This hasn't got any oil on it, so it's a little bit rusty sounding. But again, what we're looking for is the pivot winding its way into a bearing that's either not uprighted or it's just too tight and it hasn't been broached from both sides with a tapered broach to finish the bearing hole. This is where that method, I know it's highly controversial, is that the broaching from both sides is brilliant because it's great for end shake, for uprighting issues, sorry. So yeah, you're absolutely right, Derek. Particularly if you're new to this and you see a clock that's either recently been cleaned or even worse, been cleaned and had some bushes, check for end shake. Otherwise it will come back and bite you. Okay, so let's get, it was the warning and thingy, wasn't it? Gathering. Now, as I say, I've been out and about this week, so I'll just have to gather up the depthing tool. But somebody on Facebook actually said today, somebody's making a depthing tool. It'd be brilliant to see how that turns out. I think a couple of us sent some dimensions, and somebody said, I'm a beginner, what's a depthing tool? So this is where your depthing tool comes in, unless you're new making, whereas you need a depthing tool the whole time. I think huh? Really good. Oh, really good. Right. My special depthing tool stand. So we're just doing this as a demonstration because we're trying to learn stuff. I hope you can see that. Let's just move away a little bit more. So we set the wheels up in the runners. Not particularly bothered which way around they go. And all this enables us to do in this case, just backtracking a little bit, we were testing the maximum and minimum center distance in the frame. And if for any reason, like these wheels, at neither of those positions were very good, we're just going to test it in the depthing tool. And if we find like a sweet spot of really something that's significantly different from what we can get in the frame, then yeah, we might look at comparing that to the frame and then maybe doing some bushing, which would be fun, but probably not. Right, I forgot to say. So many wheels and bits. Just move that along a bit. Now, what I want to do is to get the gathering wheel here so it's running in the track, the worn track in the pinion. I think a lot of people call that cut, by the way. So if you come across a pinion that's described as cut, then I'm going to put this on it has to go on the square on the end. I think that's all right for this exercise. We won't put much pressure on it. Good. Right, okay, so let's just bring those together until they begin to mesh. And again, it's important here, I think, to remember which direction the wheels are rotating. So I'm just going to have a you all doing out there, Rachel? Yeah? Right, okay. So that's got them lined up with their sort of natural position. Let's just, so what I'm going to do is just check that this, so the gathering palette, it gathers that way, it doesn't, so it rotates this way. So we start with the wheels completely independent, like this, and then we slowly bring them together. And what I'm looking for, they look really grubby underneath the camera here, but I don't think that affects our depthing. Too close. It's I'm moving them apart through that kind of sweet spot. No, too close together. And what I would normally do is I'd do this kind of 3 times. Each time probably put a little pencil mark on the position of the depthing tool, just to get what I think is the optimal depthing for this pair of mobiles. So yeah, run in that direction. It's about there, and it's, yeah, as I suspected, it isn't particularly smooth. I wonder why. Let's just have a little look and see if there's anything with the design. Yeah, I think it's just that the ogive, so the shape of the driving wheel here is really a semicircle. I think, I don't know anything about gearing, but I think in normal cycloidal gearing, you'd expect a kind of pointed ogive. If you look at the kind of classic Swiss standard, the NHS standard, you have a very long ogive. Here it's just a semicircle. So what's happening is that the driving wheel is kind of leaving the pinion earlier than it would if it were a little bit more pointed. So the incoming tooth is touching that a little bit sooner, which is causing a butting. Now you can get around this a little bit by moving those center distances together, but you can't get around it any more than that because it's just the way that the thing was made. So it really doesn't improve it massively by moving it further together. But let's just say, for our sake of argument, it was, and we'd realized that either that clock had always been like that, or it had been bushed, or the hole plugged or moved, or a new wheel or something that meant that we'd found a more optimal center distance with our depthing tool. What do we do next? Well, we transfer that value, that center distance, to the plate. We can measure it across here with a caliper and deduct 1 diameter. But what I'll just do here is, there is a little screw on here which never seems to work for locking it, so I just won't move the, let's just take those out, and we can use that end. I'll actually just take those out so they don't stab me in the eye. And here. So what we need to do here is to make sure that the runners are pretty much the same length. We don't want to put the depthing tool on the plate at an angle because that'll distort our center distance. So just get a bit of brass. And that's probably not the way I'd normally do it. I'd probably just put it on the bench. But anyway, just check our runners are extended by about the same amount. You can see here, this is why it's important that the runners on the depthing tool are, well, not absolutely parallel, of course they're not, but as parallel as you can be across the length of the thing, because you might have one value in the middle, but if they're not parallel, then you're going to have a different value at the ends. So if you buy a second-hand depthing tool, particularly one of these cast brass ones where the brass is quite soft, you need to check that first. And you just simply check it by scribing two circles, one with one end, one with the other end, and check that they do in fact agree. So what I would do would be to, let's have a look here, very gently compare the two sides. I'll make sure I get the right hole, because that would be embarrassing, wouldn't it? Now, of course, there is a bit of an alarm ringing here, isn't it? Because of that extended bush. It's obviously been bushed, and we think, is that a problem? Is that the reason why these two mobiles aren't depthing properly? And it does make it a little bit trickier, because we'd have to offset the runner for this side. But let's just have a look. So I'm not sure I can do this easily on my camera. Well, this is what you would do. Bring that round until it was perpendicular. And then you have to ask yourself, oh, that's not right. Have to ask yourself, is that, do they agree, basically? This is going to be tricky. I mean, they do pretty much. It's slightly difficult to see on the inside. And I do wonder whether that extended bush is kind of slightly cockled over, because on the outside it looks fine. On the inside, it is slightly further apart. So anyway, so that's the principle of the depthing tool. If you've got a pair of mobiles that you are not that you maybe think maybe they could operate outside the center distance that's offered by the clock frame. Okay, enough of depthing for now, I think. Let's go back to our spring. And actually try and start a repair eventually, finally. So where is it? So here we are. Da, da, da. Now this repair is going to be made slightly more difficult by the fact that we can't easily get this out. I want to try and do it with this click in. I don't want to start wrenching at that riveted thing. When these wear so badly that they're flopping right across, by the way, sometimes you see people put a saw mark in the back to keep the spring and the click aligned. But what you basically have to do is to cut off the worn thread and silver solder a new piece of metal on that's already threaded. It's a bit of a faff, but it can be done to rescue the click. Right, okay. So, yeah. Yeah.
If they don't line up,
yeah.
Please explain how you would go about sorting it out.
What don't line up? The depthing tool and the bushing. I think that's what Derek means. If the depthing tool doesn't agree with the bushing, what do you do? Is that the question?
I don't know.
Oh, answer it in the thing, and then yeah, I've got an answer to that. Right. Okay. So if we're going to replace this, I'm still not quite sure which one it is. Striking side, click spring. Then we need some metal. Now, if you use something like CZ121, which is a leaded brass, that's great for free cutting machining. But the thing is, it doesn't bend very well. It won't cold forge. And what we want to do here, once we made the spring, is to turn the end over. So we could make the spring in CZ121 and then it snaps off at the end. What I'm going to use, because I've got some in stock, is CZ108. Now, this is rolled material, so it's probably what the manufacturer calls half hard. Now, we want this spring to be springy, and you make brass springy by work hardening it. My slight reservation here is that the spring is just about 0.8 millimeters thick, and this is already about 0.8 millimeters thick, so I don't want to make it much thinner. But what I should really do, of course, is order some thicker material, but I want to at least make a start on it today. So you can see this is already quite springy, but I'm going to improve that by hammering it a little bit. So this is CZ108, so I don't think it's got any lead in it, which means it's a real pig to machine or file. I'm going to use a piercing saw. It's going to be terrible to drill, not nice to work with, but it's brilliant for cold working and makes really great springs. So I suppose ideally, I might look for a piece of CZ120, which I think is about 1% lead, so some lead, but not as much as CZ121, which would be a good compromise between the two. But this is an exercise, really. I don't have that in stock. I might order a piece, so in case this doesn't work out, we can go back to that next week. So I am going to work harden this a little bit more, but I don't want to work harden the whole thing. So let's just have you can actually see at this end, look, I've already made a spring. I think that was a fly spring from this end. You can see how it's squidged out where I've really forged it down. I don't want to make it too thin, otherwise it's going to be too thin. I'll have to start again. So first thing I'm going to do is just chop a bit out, but let's just make sure that our new spring is actually going to fit from it, because that would be unfortunate. Okay, but rather than cutting this out, I might just leave it and just hammer it a bit as it is in the material, because otherwise I know what's going to happen. I'll cut it too small. So
yes, so I think your understanding of the question is correct. All
right, okay, so they, oops, all in my paper. So the depth, what would you do if those distances were different? So you think, right, I'm going to bush that hole. Well, this is in our bushing and depthing chapter when it eventually comes out. But anyway, remember you've got two, we were looking at pairs of mobiles. Once you decide to move one, which you would do there because you want to reduce the center distance, you've got to think, if you've got three mobiles, you know, the one is in the middle, is planted as a function of the other two. We just looked at one of those pairs individually. So you've got 6 pivots there. So your next thing is say, right, which of these pivots is an immovable object? In that case, we've got a gathering wheel and we've got an escape wheel, warning wheel. And the pinion, so it's a driving wheel onto a driven pinion. So we want to move one of these two, and we just look at the frame and say, well, obviously, if we move this, we're also affecting the distance, we're likely to affect the center distance of the driven in mobile. And if we move this, we're going to affect the center distance of the fly to warning wheel. So my feeling here is you just look at the frame and decide which, or maybe both of these pivots are you going to move? Because you can move one of these, and although it affects uprighting, if you move this pinion end, doesn't affect the depthing that much, tiny amount of this end. So you can, we're talking maybe 0.15, 0.2 of a millimeter, so a tiny amount in this case. So if it was this pinion, for instance, you'd go, right, this is going to cause us a problem, because if we want to move this bearing this has also got the gathering pallet on it. So that's going to affect its relationship with the rack and gathering. Same for the center wheel, same for the escape wheel. They've got things coming out through the dial that are going to change that. So you've got to go through this whole process of saying, right, do I need to move one or more bearings? And then which one am I going to move? I think probably here, because it's this driving this, I would end up moving this one. And I think this is the one, isn't it? That's already got that extended bush on it anyway. So that looks like our culprit. Now, you could either say, I can see it's closer and clockmaker's thumb in the air, let's move it across by 0.2 millimeter, for instance, 1/4 millimeter. Or what you could do, because that is quite, a lot of people say that extended bush is ugly and don't like it anyway. As you know, I'm very fond of it. But you would plug that hole, so get a bit of cast brass and make a plug, solid plug, and rivet it into the plate. You'd have to open the diameter up a little bit. And then using those points on the depthing tool, you would re-scribe and re-drill the center. So in that case, because it's got that plug in it, it's that extended bush in it, it's already a bit of a mess, I would just get rid of that, plug the hole with cast brass, and then re-scribe. So you've got two crossing lines. You've got the gathering wheel to warning pinion, and then you've got the warning wheel to fly distance to give you a completely new center. Obviously, all the time you're kind of thinking, does this make sense? Does it broadly agree with what was there before? And all those kind of questions. So you plug the hole basically in this case.
Just check.
Yeah.
We asked the questions, and it was the second time said, if bushes don't line with depth into them,
Yeah.
do you put a solid bush in, then drill and broach the hole, or what?
Yeah. In that case, because that extended bush is a bit of an animal already, yeah, I'd probably just say, right, we're doing away with this. We're going to put a plug in, yeah, solid bush, if you like, of cast brass, rivet that in, not changing the surrounding material. The minimal wall thickness we think we can get away with, because we don't want to remove material from the host plate unnecessarily, and then scribe two lines of those two pairs of mobiles I've just described, center punch, drill, and then broach on both sides, and there's your new hole. That makes sense? Yeah.
Would you not just do the one that has an elongated hole?
No, I mean the elongation of the hole is a kind of indication, but maybe if it's a relatively modern, machine-made clock, then you can probably put a bit more emphasis on it. But you've seen from Open Clock Club, you've seen from this clock, and I'm sure you've seen from your own clocks, that so many layers, the sort of sedimentary layers of change, of intervention have taken place, that wobbling pivot hole thing, yeah, it's a good indication. That's where you focus your attention, but that is not the absolute sort of arbiter of where you rebush, because when the clock's running, that pivot doesn't wobble in the hole. It's pushed against the pivot wall and it stays there basically, unless it's the pallet arbor that's got that reciprocating action. So yeah, it's an indication, but it's not an absolute. This hammer's a bit small actually. It'd be nice with a planishing hammer, but I don't have one. So. You get the idea. It's better with a planishing hammer. But we're work hardening this. Of course, with brasses, you can easily push the material in both directions. So you can both work harden by working it, hammering it, drawing it, spinning it, or you can anneal by heating to dull red and then allowing it to cool naturally, or quenching, which you do in silversmithing, where you're raising an object and it work hardens. So to prevent it from cracking, you constantly anneal it and so on. But anyway, for the sake of demonstration, it has actually made quite a difference to the feel of the that bit of material, just that bit of hammering. We could do more, but as I said, I don't want to thin this bit of material out too much, otherwise it's going to end up too thin. Now, to get the pattern from this, I can either start from scratch, or I can draw around this. Now, what we've got to be careful of here is that this might have been bent, and of course we don't want the top of the spring here to interfere with the meshing pinion, the pinwheel pinion. So I'm slightly reluctant to do that, but we do know that we've got a radius here, and that our spring at no point comes inside that radius. So easy life, we can use a pair of dividers or even our depthing tool. I'll use the depthing tool to scribe that radius, and that'll get us off the starting line. And all I'm going to do is scribe another one that's basically the width of the diameter of the teeth. So take that value, that value, and that value, scribe 2 lines, chop it out with a piercing saw, then we can file it flat. Then I'm going to pin it on, and then I can determine where this point is here, see if any more hardening needs to do, then I can cut away the rest of it. All sounds pretty simple. So let's just have a measure up wherever. Well, I'll tell you what, as the depthing tool is here, might as well, there's a...
So, when you answered that other question, so thank you, and said, would you scribe using the depthing tool?
Yeah, you scribe using the depthing tool. That's what those points are for. But comparators, if that's the right word, and also, yeah, you scribe with the depthing tool. But of course, you only scribe on the new material, not on the host plate. And somewhere, again, in our chapter, which will be out before Christmas at this rate, we show old plates that have got those marks on them that were made by the maker. So let's just rough this. Roughly there. I'm gonna have to get my depthing tool in here, so I need to lift up the thing. Can I get it in? Just. No, can't. Still quite squeeze it in. Should have probably been a bit more sensible just to use a pair of dividers, but there you go, as rough as you like. And just double check that that's actually going to give us what we want. Yeah. Just about, could have been slightly more generous, but good old Yorkshire. So it's, I'm just going to chop that out roughly because I want to pin it on first. If you're making a component like this, and I'm not really a maker, but anyway, don't drill the hole or pin last, because you can never get the hole where you want it. Drill the hole and then make the component down to the hole. That's how you get the hole in the middle or in the place that you want. Don't do it the other way around. Okay, so let's get our piercing saw and find it, which is there, and piercing saw table. Say we Okay. How are we doing for time?
3:57.
Fine. There's lots of junk under the bench. There you go. Right. So, join. Somebody was asking the day, wasn't they, about piercing saw blades. So let's just. Here we've got thin material, so you want quite a fine blade. And it would be useful if I could see. Probably here, there, the blade getting a bit blunter towards the end. This is CZ108, as I said, so it's quite sticky. You can see it kind of picking the material up, but anyway, that's a bad workman blaming his tools. I'm not sure we're going to get through this. Right, okay, there we go. So we've got now a spring. Spring part one. Let's just check before we go any further. I haven't cut it too small, otherwise start again. Maybe it can actually go that way around. Just about okay. There isn't masses of room there, but we're just about okay. Brilliant, good, just done that. Next thing is to get this one off. Now I want to get this off without damaging it too much. Now it might be I think this has been riveted on the back, because sometimes those pins are just pushed in, but this is riveted, so I think it's not going to want to. No, I'm going to have to file the tops off those rivets. Now, of course, here, as much as I don't really want to do, we're going to get rid of the spring. It'll go on with the clock in a little bag, and the reality is it'll not survive with the clock, which is a great shame. But you can't keep everything, I suppose. And so rather than filing on this side where I'll damage the wheel, I'm going to file on this side, but I'm going to file through a bit of paper just to try and still protect the spring as much as possible. Got our invoice here. I want your side. So fine file, a little bit dirty. Just get a bit of paper. I mean, this will inevitably cut through the paper and mark the spring, but I'm just trying to minimize that. We use a bit of like a polyester film here, the stuff called Melanex, or in the old days when we all used to have 35mm film kicking around, we used to use a bit of that, which is good. It's just a bit thick, that's all.
One using something like a laser cutter to form new pieces rather than sewing, or the sewing together.
No, you do it how you want. Laser cutter, 3D print it, spark corrosion. For me, it doesn't matter. I've got zero interest in making the thing look like it was, because of course, one might argue that a thing that is, you try and make it look like the original, is actually further away from something that is just made. I think there's a kind of joy in just making it. So yeah, I don't mind how it's done. I mean, what you do need to kind of respect, if you like, here is the nature of the material, in the sense of, if you're going to use brass, then it has to be springy because it's a spring, and it has to be reliable, but you could change the material. I really don't mind in the overall makeup of things. Yeah, I mean, people get very excited about using cast brass or using, color matching and that kind of thing. But yeah, no, don't mind. Whatever. I think it's great to be experimental with this stuff, because it's all about learning, really. Well, they are well.
Ian uses masking tape instead of paper, and Jeremy uses all film negatives.
Yeah, the 35mm or the negatives. Yeah, Jeremy probably uses medium format, what I like down there. But the Hassel, is it from the Hasselblad, Jeremy? Sorry. Film is great, and a masking tape. I wouldn't have thought of that, but I've got some here, or some brown tape. Anyway, I think I'm going to have to give those. Sorry for being cheeky. Give those rivets a little bit of a tap with a punch to get them out. Yeah.
Derek thinks you should only use handmade clock parts, not 3D printing on the rivets.
Right. Okay. Yeah. I mean, it's a good question about how you make new parts. For me, I suppose it's each to their own, isn't it? I mean, I make them by hand like this because it's cheap, it's easy, and it's quick. in the old days, I used to have a bit of CAD software, which I really loved making. And this is really leads me on to our sort of like wanting to do lots to these old clocks. Really, if you want to do lots to old clocks, I would say just make new ones, because that's mega challenging and great fun as well. And then you can do all sorts. We've done spark erosion before. We made a double pendulum grasshopper escapement clock, a resonator clock at the college, and that was great fun. We used spark erosion for that. And you know, I don't really have a preference either way. I mean, there is an argument, of course, with this stuff for keeping the craft alive as well as keeping the clocks alive. And hopefully that's a little bit what these sessions are about as well. It's about exchange of information. So you can see where these are really smooth, these rivets now, but they have been riveted in there quite tightly. So my next step is to punch them down a little bit to get them out. I suppose you could, somebody a few weeks ago was talking about alum one day about, you know, rusting them out, because this is all brass around here. You could put it in some chemical, I suppose, that rusts the pins out here. But anyway, Jeremy, yeah, in the back of the
No.
Has he got a Hasselblad?
No.
Right.
It's 35 mil.
All right, okay.
Honestly.
I'm only jealous because I've never had medium format camera. I remember when those Contax medium format cameras came out. I've forgotten to call them now. About 20 years ago, I think. It was just when digital was starting, and then Contax and I used to, in those days when I had money, have Contax kit, and then it was just really tempting. And then, of course, they nosedived because digital came out, and I saw nowadays they're actually becoming sort of collectible and popular again because they're really good quality. So that's nice to see. Anyway, cameras.
He says it's tempting to see how well an entirely laser cut clock would work.
Well, I've never done a laser cut clock. You know, remember those wooden pinions we got were laser cut for the kind of demo, which is great, and didn't seem particularly accurate, but I suppose that's all to do with the quality of the machine. But spark eroded works absolutely brilliant. We've got a lot of pictures somewhere of our whole, but I've still got one of the wheels somewhere. And of course you can do crazy things like we had the crossings so thin that you could kind of flex them with your finger. So you can do all sorts of cool stuff, I suppose, with spark erosion. I don't know about laser. I suppose the beauty of laser is it's relatively inexpensive, and you can maybe do that at home. I don't know. Right, I'm just going to tap these rivets out. I can see them. Right, let's see if we're any closer to being liberated. Yeah, I mean, that's where they've cracked this this whole spring. So it's really riveted down. I nearly got the scalpel in my finger. There we are. Sorry, on the floor. So there's our spring. And yeah, I had to file some of it away to get it off. So a little bit distressed about that, but at least we've got a pattern, haven't we, for our new one. Let's just check it's gonna fit. Is it too short? Gosh. Might I don't know if you can see that or not. It's pretty close. Might be okay. I might have to do another one. I probably couldn't too short. But anyway, If I need to do another one, I'll do that during the week. So the next stage, need to get these pins out here, but we'll probably call it a day at that point, is that with my slightly longer, in fact, if I just work hard on this a bit more, it'll stretch it out a bit. It's going to go that way. Which way around? It's going to go that way around, isn't it? Going to sneeze. So I'm going to put that on there, and then I'm going to mark through from the back. We'll do this next week. Drill it, pin it with brass pins, temporarily long, tapered, hard brass wire pins, and then we can make a decision about the overall shape of the thing and start cutting it down. But we should get this done next week, I think. And what time is it? Okay, it's 7:45, so I think we'll probably call it a day there. As always, let's keep in touch on Facebook. Thank you for joining us. Hope it was fun. Hope you learned something. We certainly enjoyed the live chat. See you on Facebook in the week. See you on Saturday, Open Clock Club. Hopefully, forgotten what we're doing, putting our Smith's clock back together, I think, with the spring that sort of sent us off a bit of a tangent. And as always, to these events, thank you to Team Open Clock Club across there who have kept the live chat going. So hope that was fun. We'll continue with this next week, hopefully get this spring finished and move on to our next rather long list of repairs. So take care and see you again. Thank you.